Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 24th of June, 2025 T, 10 hours, 40 minutes, and 23 seconds, .000Z. This paper, published just 2 days ago, introduces a specialized model that outperforms even GPT 3.5 Turbo on identifying what kind of accessibility conversion a user needs. The paper is titled MATE, LLM-Powered Multi-Agent Translation Environment for Accessibility Applications, and it proposes a really thoughtful framework for using AI to help people with disabilities. So the authors build an open-source system that uses a team of specialized AI agents to handle different data conversions, improving digital accessibility for everyone. Alright, so this diagram really breaks down the workflow of the MATE system. A user starts by making a request, which goes to a central interpreter agent. This agent is essentially the brains of the operation. It figures out what kind of data conversion the user needs. It then routes that task to the correct expert agent. These experts handle specific jobs, like text-to-speech, which reads text aloud, or image-to-text, which creates a written description of a picture. After the conversion, the output file is sent back to the user. Building on that workflow, this table details the specific agents in the MATE system. You see the interpreter agent at the top, which uses their custom ModCon task identifier model to figure out the user's need. Below that are the expert agents, each designed for a specific data conversion or modality, which just means the type of data, like text, audio, or image. For example, the speech-to-text expert takes an audio file and creates a text transcription using a well-known model called Whisper. This shows the system's modular design, using specialized tools for each job. Moving to the results. These charts compare different models for that central interpreter agent role. The top grids are what's called a confusion matrix, which is just a grid that shows how often a model's prediction matches the true task. A strong, clean diagonal line means high accuracy, and you can see their fine-tuned BERT model, in orange, is nearly perfect. In contrast, the general-purpose GPT 3.5 Turbo model, in green, makes more mistakes. This really shows that their specialized model is the best tool for this specific job. This table then drills down into the performance of different off-the-shelf LLMs for that same interpreter agent job. We see a few models here: GLM 4 Flash, Llama 3.170B Instruct, and GPT 3.5 Turbo. They're measured on accuracy, precision, and the F1 score, which is a balanced measure of a model's overall performance. So, looking at the numbers, GPT 3.5 Turbo is the clear winner among these general models, with the highest scores and an impressively low failure rate. This reinforces that while a specialized model is best, a capable general LLM can still do a decent job. Alright, so this final table gives us the full picture, comparing their custom model against a whole suite of others. The top sections show results for classic machine learning models using two different methods for understanding text. The first is term frequency inverse document frequency, or TFIDF, which is a way of counting important words. The second uses the more advanced BERT model. But the real story is at the bottom. Their custom ModCon task identifier model achieves an F1 score of 0.916, a massive jump over every other model, including GPT 3.5 Turbo. So, what this all comes down to is that the MATE system is a really promising step forward for digital accessibility. It's an open-source framework that uses a team of specialized AI agents to handle different data conversions, like turning an image into an audio description. And the key takeaway, really, is that building a custom, fine-tuned model for that central interpreter agent role, that ModCon task identifier, makes the whole system much more reliable than just using a general-purpose LLM. This specialized approach is what makes it so effective. Thanks for tuning in.